So this is relative motion. And suppose you have two cars. A and B. And say B is going in the negative direction 50 miles per hour. Car A is going to the right 60 miles per hour. And so B is going west. And so you could maybe say the velocity of B, if you count that as the negative direction, velocity of B is minus 50. And the velocity of A is a positive 60. So if you're in car A, how fast is B moving? Or, yeah, how fast is B moving, say, relative to A? So in other words, so if you're seeing car A and it's going 60 miles an hour this way, car B is going 50 this way, it would appear to you that B is moving like at 110, huh? Miles per hour. If you're in car A and you're looking and seeing car B, it looks like it's moving that fast. Or, you know, and that is like in a negative direction. So we say, and this is the terminology, we say the velocity of B with respect to A is, and we probably should put the sign is minus 110 miles per hour, mainly since B is moving like in the negative direction. So it would appear if you're in A that B is moving in the negative direction, minus 110 miles per hour. And that's pretty logical, right? If you're in the car and you're moving one way that fast and something's moving the other direction, it's going to seem like 110. Now, formally, we write it this way. Formally, this is the equation that we would use. Velocity of B is equal to velocity of A plus VBA. And this means velocity of B relative to A. Is when you have a B with that slash there, that's what that means. So if we were to put our stuff into the equation, we know B is moving at minus 50. A is moving in the positive direction, it's 60. Velocity of B relative to A, if we bring that over the other side, B relative to A is minus 110 miles per hour. So that's the way that you would sort of formally do it, like that. Now, to find the velocity of A relative to B, we do it this way, VB, the other way around, VA equals VB plus VAB. So when you set up these equations, you can see the way it is. If you have A on the left, then right over on the other side of the equal sign, you'll have a B, and then it'll be whatever this one is on top, and then the other one on the bottom. Because before, when we had B on the left, we had VA on the right, and then B on the top and V on the bottom. So you can see the pattern: B here, B here, A here, A here, A here, A here, B here, B here. Though this will be on your equation sheet. You don't have to memorize it. It makes it handy though if you know it. So now again, to find the velocity of A relative to B, then put the velocity of A in, velocity of B, plus the velocity of A relative to B. Again, we have it like this. Velocity of A relative to B. And when you solve, you bring out the other side and solve it, you have velocity of A relative to B. If you're in car B, it looks like A is moving in the positive direction, 110 miles per hour. Any questions on that? So pretty straightforward. Any questions at all? Okay, good. So now, again, we didn't need the equations for this, but unfortunately, usually things aren't moving, along the x-axis strictly. So we have to do the same thing except with vectors. So usually, motion won't be confined to x-axis. So we use vector equations. And that would be simply the same thing with vectors. The vector B equals the vector A, vector B plus A, or if you use the other equation, vector A equals vector B plus A, B, like that. So same equation, just with vectors. So let's take a problem from the book here. This may or may not be from the book. So let me just write it down. So let's say if you have these two things moving along. And say you have two cars. Now this time, the cars are not going to be going along horizontally, but one will. And so let's say you have cars like this. You have maybe this one here. Car A going at 100 miles per hour. And maybe car B going in this direction, 80 miles per hour. And we want to determine velocity, find velocity of B relative to car A. So this is what our problem is this time. And so again, we're gonna have to use vectors. So let's see if we can do this. So once again, if we were to write these as vectors, what we can do is just say, okay, car A is going to be VA is what, going to be 100I, huh? And that's going, in the positive direction. And then car B is what's that going to be 80J, huh, in the positive direction, like that. So now if we want to find the velocity of B relative to A, we have to use the equation that has B over A. So that would be this equation here. And now just plug everything in. So plug this one in over here. Solve for VB over A. And we get 100I plus 80J. Like that. So in other words, if you're in car A over here, it looks like B is moving this direction, minus 100, and this direction, 80. So in other words, if you're in car A, it looks like B is moving this way and this way. So that, I guess that would be something, it would look like B's coming at you like that, huh? If you're in the car, it looks like it'd be coming sort of in your direction, which I guess it is, obviously, but sort of at an angle. Any questions on that? Okay with that. So if we start with these simple concepts, these problems are actually pretty easy, and just have to kind of build on them. And let's do, actually, let's do, this is 12F1246. This is also on page 97. And I'll put the picture, but that's 12F1246, page 97. That picture in the handout's pretty hard to read. Let me write it on the screen here. So we have these two airplanes taxiing. And traveling with constant velocities. And so we have again this one plane coming this way at 650 kilometers an hour. And then we have another plane coming down in this direction, and we're told this is 60 degrees. And this is, and they call this one, this is plane A. This is plane B. It's coming 800 kilometers an hour. Like this. And so once again, we want to find velocity of B relative to A. And so just like before, the first thing we want to do is make the equations for each one. VA, what that could be 650I plus, you can put the 0J if you want, but it looks like it's not really necessary. And velocity of B, let's see, what do you think the velocity will be the I component velocity for B? What would that look like, do you think?
That'd be 800 cosine 60.
800 cos 60I. Is there, how about the sign in front of here? Would that be plus or minus? Minus. Good. Because you can see it's coming, sort of going in the negative x direction. And then how about for the j component? What would we put for that? A volunteer. Good.
Minus 800 sine.
Mm-hmm. I threw everybody off by putting a plus there. Let's say 100 sine 60j. And when you put this in your calculator, you get VB is minus 400I minus 6, about the 693J, more or less. So we have what we need there. So we want to find the velocity of B relative to A. So once again, we need this equation. And just plug everything in. And again, you see when you put everything in terms of vectors, these problems become pretty easy. Now, if you try to solve these without vectors and actually going through all the angles and everything, get real difficult. But with vectors, it can become very easy. And then solve this. And it becomes a, let's see, you put this over here with that minus 1050I and then minus 693J, like that. And that's the answer. Let's see. Yeah, if we wanted to find the magnitude, it looks like in this one asks us for the magnitude. And the magnitude, if we want to do that, would be this. Just the square root of some of the squares. And I get around 1258 kilometers an hour will be the velocity. And you could find the angle, let's see, determine the magnitude. Yeah, okay, if they want the direction, they implied they might want the direction too. So if we do the direction, if you look at this, so again, if you're in B, let's see, if you're an A and you're looking at B coming down, it's gonna be like minus 1050. It's like, this would be like 1050 here, minus 1050. And then this one over here is like minus 693. And so if you want to find the angle here with the horizontal, it's going to be tangent theta equals minus 693 divided by minus 1050. When you do this, you could just leave the minuses off when you do the tangent, but I'll put them on anyway. So bank could put it in your calculator at 33.42 degrees is that angle from the horizontal. Any questions on this? Any questions? Everybody okay? Okay, let's look at some more here. And let me look at oh yeah, 12-214. That's on page 100 if you're using the book. So now we have to do a little bit more, but we have to use the stuff we did before. And you'll kind of see why we kind of reviewed vectors before, because we're going to need a little bit of stuff now. So again, 12-214, they have like a car coming in here. This is car B at 18.5 meters per second. And up around here is car A at 10 meters per second. And car A is going around a curve of a radius of 100 meters. And so this is a constant. It looks like it's a circular area where he's going to be at here. And so, and also we're told in the problem, this guy here is increasing at 5 meters per second. So acceleration, and that's going to be like the tangential acceleration. Whenever they don't say it, it will always be the tangential acceleration. And car B is increasing its speed at 2 meters per second squared. So let's put that at car B, 2 meters second squared. So this time I want to know the velocity. Find velocity and acceleration. Velocity and acceleration of A with respect to B at the instant shown. So first of all, let's start out with the easy one. We'll do B. So the velocity of B in vector form is just going to be what, 18.5 I. And if you want to put the 0J, you can. And the acceleration of B, again, this is just at that instant, is going to be 2I. And now the thing, now here the thing with A is we have this tangential acceleration, but since it's going around the curve, we also have that normal acceleration we had before, huh? It's going to have a normal acceleration inward. So here's where we have to use that vector stuff that we practiced previously. So we're going to have a picture like this. And so we're going to have our tangential velocity, tangential acceleration. Those are the ones that are given, the tangential. We're also going to have this normal acceleration, AN. And so we're told, well, actually, yeah, this one shouldn't be too bad. We're told, because we're given this as 45 degrees. And so, let's see. So then also, let's see, we're going to have to use a little bit of stuff here. Let's see. Okay, if that's at, actually, if that's at 90 degrees, this is going to be 45 degrees as well. So that's this picture of car A, just re-shown down here. And so let's see if we can do this. So the velocity of A, velocity of A is going to be, again, this is at 10 meters a second. So it looks like it's going to be 10 cos 45 degrees, and that's the I. And then it's going in the negative y direction, minus 10 sine 45 degrees J. So it's 7.07 I minus 7.07 J. And so we have that equation. And so we're going to use those two to find the velocities, but we're also going to need acceleration now. So let's do the acceleration. And so the acceleration for A. So let's see, we may have to stop for a second. Remember, AN, we're going to need the normal. Remember, the normal acceleration is the velocity squared over the radius of curvature. So that's going to be, this is going to be 10 meters per second squared over 100. And that's going to be 1 meters per second squared. That's going to be our normal acceleration. But now we're going to have to put that in vector form. So the A of A. Now again, for the I component, we have to be careful here. So the I component, we have this tangential velocity tangential acceleration, which is this. So it's going to be 5 cos 45 degrees. But then we need the I component of this normal acceleration too, right? And let's see, what does that look like? That's going to be. So we know that's 1 meter a second, and it's going in this direction. Would that be minus 1 cos 45? Does that look right to everybody? If we have that, if we have the tangentials there, 5 cos, the normal is here in the negative direction, minus 1 cos. Then for the J component, we'll have, I'll put a plus, and then for the tangential, again, for 45, this is going to be sine. It's going in the negative direction, huh? Minus 5 sine 45 degrees. And then for the normal, it's also going negative, and that's going to be sine, huh? Minus 1 sine 45 degrees J. And if you put all this stuff in your calculator, the acceleration of A is 2.82 I minus 4.24 J. So just take a look at that for a second. See if that all makes sense. So we've now found accelerations here. And we have velocities here. Does that make sense to everyone? Any questions? Any questions on any of that? Okay, good. Now, once you've done that, you've done all the work. The rest of it's just mechanics. Just plug everything into those equations. So just now use the VA equal, let's see, is that the one, the velocity of A out? VA, VB plus VAB. Then just plug in all your stuff that you just calculated. And for VA, we had 7.07 I minus 7.07 J. And for VB, we had what, 18.5 I plus velocity of AB. And when you solve this, you get VAB equal minus 11.43 I plus 7.07 J. And then there's a same equation for acceleration. It's exactly the same form. Exactly the same form as the velocity. And just plug in your acceleration stuff. And what we said that was for B was 2I. And then acceleration comes out to, if I did this correctly, 0.82 I plus 4.24 J. And if you want to find that, I think they may ask us for magnitude and stuff, but you could just do that pretty easily.